So let me turn first to Amy. She'll give a very general perspective, I think, of what the American Physical Society is doing in this area.
All right, well, Bill, thank you for inviting me to talk. And I know a lot of you in this room, but I'm Amy Flatten, and I'm Director of International Affairs for the American Physical Society for about 11 years now. So, as some of you probably in this room, I know, are members of the American Physical Society. And just to give you a quick overview of what the APS is doing in international affairs, let me start off by saying to those of you who might not know us who we are. The American Physical Society is a membership organization of over 50,000 physicists worldwide. Most of you who are physicists might know us for our meetings, our big March meeting of about 10,000 physicists and our smaller April meeting. These meetings can occur any time of the year, by the way, but they're still called the March and April meetings. They represent the different subdisciplines of physics. But we also have cross-cutting programs that affect all subdisciplines of physics. And the one I'll talk about today is international affairs. But even then, international affairs cuts across all aspects of the APS. International issues cut across education, policy, industry, and research. And what many of you may not realize, in fact, a lot of APS members didn't realize this, is 23% of our members live outside of the United States. If you take out the student members, then about 25% of the working scientists that are members of the APS live outside of the United States. So as Bill said, I'm going to give a general overview. What is APS doing in the international arena, and how do the scientific diplomacy drivers underpin all of our activities? So we talk loosely about the scientific diplomacy drivers, and let me give you what I believe they are in terms of the APS. Okay, fostering communication. We heard earlier, and we scientists have often used the example of how during the Cold War, lines of communication between scientists and scientific cooperation continued even during times of political strain. This is a scientific driver we're probably most familiar with. Capacity building. Science and engineering leading to economic growth. When I was in my previous job at the White House Science Office, we had commissions that fostered science and technology capacity building to lead to economic development, believing that economic development led to political stability. Political stability, of course, affects foreign policy. So this is clearly a key science diplomacy driver. This is one I care deeply about. Developing global scientists. We in the United States need to especially prepare our young people for international partnerships, developing a mindset that fosters an appreciation for international collaboration. In physics, some certain subdisciplines, this happens naturally, but in some more than others, and I'll talk a little bit more about that. Shared scientific resources. We've all heard the talk earlier this morning. No country can go it alone, and this is especially true in physics. Physics is global. But moreover, much of our research is conducted with large facilities, big machines, big scientific research centers that need multinational partners to fund it and operate and administer it. So consequently, constructing agreements so that all of our partners benefit is crucial to not just US science, but to the world science. And science diplomacy is not just talk. When you hear diplomacy, you think talking. But science diplomacy in terms of APS is action. So I'm going to give examples of what we're doing for each of these scientific drivers. And then after I give the general overview, we'll hear from my colleagues from the specific physics subfields on what they're doing. So the first one, fostering communication. Scientific cooperation despite political tensions. And when we think political tensions, it's natural to think of the Middle East. How many of you, we heard about the Sesame project this morning. How many of you had heard about Sesame before this morning? Many of you have, and some of you hadn't. This is a synchrotron that's being built just outside of Amman, Jordan. The original machine was donated by the Germans, and now it's being upgraded. This will provide a scientific research center in the Middle East. You keep hearing that Sesame is going to become operational in 2016 and 2017. But here's what's key, and here's what's critical to science diplomacy about, excuse me? Here's what's critical about this project. Well, we talk about it becoming operational in the next couple years. Look at the partners in this project. They have been working together since 1999. When I was at the White House Science Office, I was writing memos for the President's Science Advisor on this. Look at the partners: Iran, the Palestinian Authority, Israel, and you see the list up there. Turkey, Cyprus. These countries have been working together for over 16 years now to set up technical advisory committees, scientific advisory committees, training advisory committees, developing a financial scheme to allow this machine and this project to become sustainable after it becomes operational. Clearly, it's building scientific and cultural bridges and contributing to a culture of peace through science collaboration. And that's great, but what's the APS doing? Okay, so here I underscore partnerships. The APS launched a program to develop a fund to enable training for scientists in the Middle East. It's imperative that we have a cadre of scientists ready and trained to use the facility when it becomes operational. We partnered with the European Physical Society to put a modest amount of funds in each year. Now, as you see, we have 7 scientific organizations across the globe contributing annually to enable a pot of money, a pool of resources, so that scientists can attend training opportunities all over the world so that they're able to conduct research when Sesame comes online. Again, this is a good example of not just science diplomacy in the Middle East, but science and diplomacy in the developed world as well. We're partnering to serve these communities. Oh, I remember, I was going to make the point, 25% of those funds are earmarked for women scientists in the Middle East, another 25% for young scientists. The second scientific driver, capacity building, science and engineering leading to economic growth. As I said, we believe science and technology fostering economic development leads to political stability. What is the APS doing about it? APS and the UK Institute of Physics, along with the International Center for Theoretical Physics, ICTP, and a number of other partners, combined our resources to hold entrepreneurship workshops for physicists and engineers across the world. We have at least 2 of these per year, typically 4 in any given year. These are teaching scientists and engineers who are technically trained about concepts that they don't get in their university curriculum, things such as intellectual property rights, technology transfer, commercialization. So here we're trying to use APS programs to foster economic growth. And this is good at one end of the scientific scale, the technology development end. But moreover, we can't have technology development unless we support the basic sciences that make technology development possible. With this, I introduce the International Travel Grant Award Program. Here, all scientific divisions of the APS, that cuts across every subdiscipline of physics, have contributed funds toward this program that give $2,000 to support travel for a collaboration between a developed country physicist and a developing country physicist. Here, these are senior scientists in collaborations, and typically the physicists from the developing country will visit those from the developing country and for data taking, giving seminars, what have you. But these proposals are invited twice a year. We give about 10 awards per year. These proposals are not only judged on their scientific merit, but they're also judged on how they will go back and impact young people in their home country. So we're supporting scientific development here in discovery-based science as well as leading on to commercialization with these two programs. So I talked about young people. That brings me to the third scientific driver. Developing global scientists, preparing young physicists for international partnerships. Here in the United States, we host a lot of international students, but US students don't have the same opportunities to travel to countries where they're getting an understanding of the scientific culture, the scientific community, and consequently, particularly with the BRIC countries, APS has started these exchange programs. We support senior scientists that want to travel and give a seminar series or a lecture series in either of the countries. But more importantly, we've developed a program so that graduate students and postdocs can submit proposals and receive funding to travel to Brazil or India to spend a semester in a laboratory or any other experience that the host, the student, and the advisor feel are worthwhile. We also have established international young physicists forums. Here we bring together US graduate students with their counterparts from other countries for conferences devoted purely to graduate students. Here, every graduate student is required to participate scientifically. These started with our Canadian, American, Mexican graduate student conferences. Here, graduate students, about 100 from North America, come together and they present their research to each other in all subdisciplines of physics. And for some of them, this is the first time that they've presented their research in English. For others, this is the first time they've presented to an international audience of their peers. But the conference is organized so that there are networking opportunities so that we can underscore the importance of international partnerships and foster an appreciation for international collaboration. Most notably, this past March, we held our first US-China Young Physicists Forum. Again, we host a lot of Chinese students here in the United States in our universities, but our US students don't have the experience or the opportunities to travel to China to understand those scientific cultures. With this Canadian, American, Mexican model, we're able to replicate that either multilaterally or bilaterally with other countries. And our fourth scientific driver, shared scientific resources, and I imagine that my colleagues will be talking more about that. In our APS April meeting, which I alluded to earlier, there were 2 scientific sessions focused purely on models of international partnerships. We have all heard the phrase, no country can go it alone, and we've all heard that physics is global. Increasingly, we need to partner with other nations for not only developing our own facilities here, but to develop perhaps a single facility or collaboration in another part of the world where our scientists can have access. There are many models of international collaboration on the large scale, and there is no model that fits all. No one size fits all. So it's imperative that create models that benefit our international partners and the United States as well. And those are good principles, but again, diplomacy is not just talk, it's action. What is the APS doing about that? In addition to presenting some of these ideas for discussion in our April meeting sessions, we also have another activity that's in development. It's a collaboration between 2 important advisory committees of the APS, our Physics Policy Committee and our Committee on International Scientific Affairs. We are going to be pulling together representatives from the physics subdisciplines to ask, what has been their experience with the international collaborations? What has worked? What hasn't worked? How should your lessons learned and your experiences inform the planning of future facilities? This is going to be an experiment, and these roundtable discussions are meant to foster small, manageable group dialogues and exchanges, first among the scientists themselves, and then, as appropriate, with the government. This first roundtable that will be sharing and investigating lessons learned will inform the second roundtable. We aren't going to be overly prescriptive. We're going to be organic. So with that, I will hand my presentation off to my colleagues because they represent those subdisciplines of physics. And let me just conclude with this one slide. This isn't a scientific driver, but this is a concern we all share. Ensuring the mobility of scientists. I want to offer this information if it can be a resource to you. The APS is very active in helping physicists who have visa problems. Please go to our website if you have any trouble, and you can find a wealth of information, or you can email me. And please let us know how we can be of help. Thank you.